Welcome everyone for today's class on specific and selective precipitants. In the last class, we have discussed and also we learnt about what is precipitant, what that is, or the precipitating agent, and also we learnt about the characteristics of the precipitating agent and choice of precipitants. In that choice of precipitant, we had the choices of inorganic precipitant as well as organic precipitants. We learnt about inorganic as well as organic precipitants, and I have explained about the organic precipitant and inorganic precipitant and the advantages of organic precipitant and some of the disadvantages of organic precipitant. Then also we have discussed and also we defined what is specific precipitants in the last class itself. What is specific precipitants? The specific precipitants precipitate quantitatively a particular ion or a substance from a solution. It is called specific precipitants. If the precipitant is quantitatively precipitate a particular ion or a substance is called specific precipitant. But normally there are no specific precipitants in reality. However, some precipitants may be are available, but they are which are nearly specific, I said. Now we have defined what is a specific precipitant. The specific precipitant is the precipitant which precipitate quantitatively particular ion or a substance from a solution, and so it is not present really. In reality, the specific precipitant is not present, but some of the precipitants are act nearly specific. For example, DMG. In the last class itself, we saw the structure of DMG and oxane. So these two examples we have discussed in the last class, and also we saw the structure of DMG and structure of oxane, how it would be, how it is. And this DMG is used to estimate the nickel ion specifically. Likewise, this oxane is used to estimate aluminium. So this is what we have discussed, and also it is used to estimate magnesium, copper and zinc ions. The oxane is used to estimate these ions too. These are all we have discussed in the last class itself, and also we saw the equations of these two estimations using dimethyl glyoxane and oxane. This oxane, the other name of the oxane is 8-hydroxyquinoline. In addition to this, we have some more examples for specific precipitants. They are given below. Cupran, cupheron and ethylene diamine are mentioned here. The cupheron is used to estimate copper in dilute ammoniacal solution, that is in the alkaline solution, in the presence of tartrate. This is the structure of cupheron. It is also called as benzoin albohexane. It is used to estimate the copper in the presence of ammoniacal solution. In the presence of tartrate. So And then the Kuferon, the next example we have here is Kuferon. The structure of Kuferon is this. In the Kuferon we have nitrogen. It is amine-like. So if we have that is aminobenzene, in that aminobenzene instead of hydrogen we have NO and hydroxyl group, then it is Kuferon. It is called as the Kuferon. This Kuferon, how we are preparing it is, it's actually the Kuferon is the ammonical salt of N-nitroso N-phenyl hydroxylamine. That is ammonical solution of N-nitroso N-phenyl hydroxylamine. Actually this is the Kuferon as the ammonical salt of N-nitroso N-phenyl hydroxylamine. This Kuferon reagent is used to estimate copper 2 plus and the ferric ion in cold aqueous acidic medium. So this all it is used to find out in cold aqueous acidic medium. Therefore, Kuferon is used to estimate copper as well as ferric ion in cold aqueous acidic medium. Next specific precipitant, we have a familiar reagent, that is ethylene diamine. This is the structure of ethylene diamine given here, CH2NH2 and CH2NH2. This is ethylene diamine, and this is also called as 1,2 di. Here we have two amine groups, so that diamino, here one first carbon and second carbon, so that we say that 1,2 diamino ethane. So this 1,2 diamino ethane is called ethylene diamine. This ethylene diamine especially used to estimate the copper and copper 2 plus and mercury, and also it is used to estimate cadmium ions. Usually if you want to estimate copper 2 or mercury or the cadmium, we can use the ethylene diamine as the reagent, and we'll get we can estimate the exact amount of these ions present in the solution. Now we know what is specific precipitants and what are all some of the precipitant or organic precipitants are nearly specific. We have discussed, and also we saw that some of the precipitant which are all used to estimate some of the metal ions. Now we shall move on to the selective precipitants. What is selective precipitants? Selective precipitants precipitate a small group of ions from a solution containing several ions. In most of the gravimetric precipitants are only selective. So for example, we have given hydroxyl ion. If hydroxyl ion precipitates a few metal ions, as there are hydroxides from a solution containing several metal ions, if we have the solution, that solution contains the several metal ions, but this hydroxide precipitates the particular metal or few metal ions only. The metal ions which are not precipitated also from hydroxides, but they are soluble and so are not precipitated. Here, there may be the presence of the several metal ions in the solution. Solution contains several metal ions. Here, this hydroxyl group or hydroxyl reagent is used to precipitate some of the few metals or few metals ions as their hydroxide from a solution. So other metals also forming, but those hydroxide salts of the other metals are soluble in the solution. And also some of the examples for selective precipitants, or some more examples: sulfide and carbonate are used as other examples of selective precipitants. Here, the selective, if we want to increase the selectivity of the precipitants, we need to we have to, the reaction should be, or the condition should be adapted in controlled manner. When controlled conditions are adapted, the selectivity of the precipitants may be also increased. Controlled condition, which means that is the reaction conditions and other the pH range and the dilutions and everything we should do here. Now we have defined what is selective precipitants. The selective precipitants precipitate a small group of ions from solution containing several ions. That is called selective precipitants. If it is the solution contains the several ions, here the particular precipitant which precipitates the particular metal ion only. If the precipitant precipitates a particular ion only in a solution, is called selective precipitants. And also we have taken and also we have given an example here. So hydroxyl ion, and also we know that the most of the gravimetric precipitants are only selective. Next we shall move on to the conditions of precipitation. What are the conditions of precipitation? Here I have given there are 4 conditions of precipitation. One is solubility must be very low. That is, when we have the ion or a substance to be estimated gravimetrically. If we are so in gravimetric analysis, we are going to estimate the ions or the substance. So that should be precipitated quantitatively so that it is to filtrate, does not contain that the substance which is precipitated. Here, so that is solubility must be very low. I think everyone you could understood. If the ion or a substance to be estimated gravimetrically, that should be precipitated quantitatively. The quantity of the precipitate is very, very important, so that the solubility of that particular formed precipitate should be very low. So if the formed precipitate is, solubility of the formed precipitate is higher, that precipitate gets dissolved in the solution itself. Therefore, the determined amount of the precipitate will be in the lesser amount, so that the exact calculation of amount of presence of ions or the substance will be getting distracted, so that solubility, the formed precipitate should have lower solubility. And the second one is the precipitate must be in the form of large particles. The formed precipitate should be in the form of large particles. If it is formed as large particles, so that it is readily filtered. If we have formed particles or the larger particles, during the filtration it is filtered easily. The filtration is also becomes easier. So the formed precipitate must be in the form of larger particles. And the third condition of precipitation is the precipitate must be pure. This is very important when the precipitate must be pure. And which means the precipitate should not be contaminated with their substances. If it contains some impurities, they must be removable by washing and drying. Suppose we should aware that the precipitate must be pure. There should not be any contamination. Suppose if there is any it contains any impurities, so that we must to remove those impurities, we must use washing and drying to remove. Suppose if the precipitate contains the impurities must be removed during washing and drying. The fourth condition is the precipitate must have a constant composition. That is, it should not change its composition during filtration or drying, or if necessary ignition, that is on heating, whatever. So it should not change the composition or the concentration of the precipitate. So if the change of the concentration is happened, the amount of calculated amount of the precipitate we are going to get is decreased, and hence therefore we will get the wrong answer as present in the amount of ions present or the substance present in the solution. So that it should not change the composition during filtration, should not change filtration, drying, and during on heating. When we are igniting, it should not change the composition. That is, should not change the composition during filtration, drying, and ignition. Now we know what are the conditions of precipitation. There are 4 conditions of the precipitation. Solubility must be very low. During the precipitate should the solubility of the precipitate should be very low, and precipitate must be in the form of large particles, and the precipitate must be in a pure form. The precipitate must have constant compositions. These are the important 4 conditions of precipitation. Now we shall move on to the techniques of precipitations. To fulfill the conditions of precipitation, the following techniques were adopted. So during to estimate the amount of the ions or substance present in the solution. Here we have the techniques of precipitation. There are 8 points you have given, 8 points we have to follow, 8 techniques to follow during precipitation. The first one, the solution of analysis is diluted. That is, the solution of analysis means the substance to be estimated. Substance to be estimated is diluted. This will enable us to precipitate the analyte quantitatively. So, before going to analyze the analyte, we should dilute the substance Then the second one is the precipitant added must be chosen. The particular precipitant we have to choose for particular ion or the particular substance in such a way that it forms. So we should choose the precipitant or the appropriate precipitant for the particular ion, whether it is aluminum, barium, or if you are going to estimate the sulfate, or if you are going to estimate ion, zinc, magnesium, whatever it may be. So we must choose the precipitant. The added precipitant must be chosen according to the ions is going to be estimated. The third condition is, not that condition, that the third point of this is, the third thing we have to do is, precipitation must be done in odd solution. So in odd solution, the solubility increases and also reducing supersaturations. So if you're doing the precipitation in odd condition, the solubility of the solution increases and it reduces supersaturation. So hence the precipitation is will be in a correct manner, and the formation of colloid will be avoided. And if the formation of colloid is avoided, and when you are increasing the solubility of the solution is increasing and reducing these supersaturations, then you will get the well formed precipitate. So precipitation must be done in hot solution. So this avoids increasing solubility and reduces supersaturation and also avoid colloid formation if we do the precipitation in odd solution or in odd condition. And the fourth one is, precipitation should be added slowly and in small lots. We have to add the precipitant in small amount, but with constant stirring. If you do like this, this will lead to quantitative precipitation of the analyte. So the exact amount of the substance to be precipitated will be precipitated exactly. And the fifth one is, precipitation is done from homogeneous solution. If you do the precipitation in homogeneous solution, that is, transparent solution, so that if you do the precipitation, the homogeneous solution, the supersaturation is minimized. So supersaturation is minimized, so that, and also it the minimization of the supersaturation, and it helps to the growth of the size of the precipitate, and it is used to increase the growth of size of precipitate. And the sixth one is, in slight excess of precipitant should be added to ensure the quantitative precipitation. So if it is completely precipitated or not, the estimated ion is completely precipitated or not will be checked by using slight excess of precipitant should be added to ensure the quantitative precipitation, the complete precipitation. Then the next one is, the precipitate is to be digested for sufficiently long time. So if you do the precipitate is to be digested for sufficiently long time to give precipitate particles of considerably big size, which will, if you do the in long time digestion, if you increase the time of the digestion which increases particle size in big size, so that it is not lost during filtration. So if we know that already we saw the condition of the precipitation, if the particle size is heavy, larger, then it is very easier to during filtration. It is very easy to filter the precipitate during filtration. Then next and the last one is, the precipitate should be washed with suitable wash liquids, containing suitable electrolyte to avoid peptization, so that the precipitate should be washed with suitable liquid to avoid peptization. So peptization, which means simply we can say that the dissolution of some precipitates, so which will dissolutes. That's a process. So peptization is a process. We shall see peptization detail later. Therefore, we must avoid peptization. And also, if the precipitate is suspected to contain impurities, if you coming to know that the precipitate is contain impurities because of co-precipitation or post-precipitation, etc., it should be dissolved in a suitable solvent and re-precipitated. So if you suspect that the precipitate contains co-precipitation and post-precipitation or some other precipitations occurred, so it is better to re-precipitate again. So far we have discussed about a specific precipitant, selective precipitants, and conditions of precipitation, and what are the techniques of precipitation we have to follow. In the next class, we shall discuss about what is peptization and how to avoid the peptization, and co-precipitation, post-precipitation, what is co-precipitation and how to eliminate the co-precipitation and post-precipitation. Everything we will discuss in the next class. Thank you.